All right, hey everyone, and welcome to today's explainer. Today, we're looking at something that is literally the absolute bedrock of modern software, and that is the foundations of string handling and text manipulation. If you are completely new to programming, you are in exactly the right place. This is the perfect starting point to discover how your favorite apps actually use text data to create those amazing, seamless experiences. We're going to build this up step by step and really uncover the hidden logic behind the software we use every single day. Okay, let's dive right into this. Take a second and truly imagine opening up your favorite social media app, right? But there's absolutely zero text. No usernames, no passwords, no direct messages, no search bars, no chat bubbles. It sounds completely impossible, doesn't it? It would literally just be a screen full of blank boxes and generic little icons. And that's because text handling is arguably one of the most critical parts of programming. For software to actually communicate with us humans, it relies incredibly heavily on text.
So here is our roadmap for the explainer. 1. The power of text. 2. Creating your first strings. 3. Combining and measuring text. 4. Slicing, formatting, and splitting. And 5. Avoiding beginner string mistakes.
Let's kick things off with Section 1, the power of text.
You see, in programming, we don't just call it text, we handle text data using what is called a string. Basically, a string is just a sequence of characters used to represent text. And when we say characters, we mean everything you can possibly type on your keyboard. We're talking uppercase letters, lowercase letters, numbers, symbols like the @ sign or a hashtag, and yes, even blank spaces count. So whether the data is just a simple hello, a really complex password, or a full welcome user profile header, the computer just sees it as a string. Without strings, AI chatbots, email systems, websites, the whole shebang simply would not function.
Moving right along to Section 2, creating your first strings. Now, what's really fascinating about this is how the core concept of a string is universal. It doesn't matter what programming language you're using. On the left side here, we have Python, where you just type a variable name, an equals sign, and your text wrapped snugly in quotes. On the right side, we have JavaScript doing the exact same thing, just with some super slight differences in how that variable is declared. But the fundamental logic, storing a sequence of text characters inside quotation marks so the software can use it later, that is identical across the board.
Which brings us to Section 3, combining and measuring text.
So how do apps actually use this? Well, this right here is called string concatenation. Big fancy word, but it's just the programming method for joining strings together. Imagine you're building a social media app. In step 1, you create a greeting variable, let's just say welcome, with a space at the end. In step 2, you pull the user's name from your database into a username variable, like Sarah. Then in step 3, you literally just combine them together using a simple plus sign. The result? Welcome Sarah. That is exactly how every single app creates personalized headers and custom messages for you. It's just concatenation in action.
Another incredibly common thing we do is check the string length. Length is exactly what it sounds like, the total number of characters inside a string. Now, why does this actually matter? Well, think about the last time you tried to create a new password and the website threw a big red error saying password must be at least 8 characters long. That system is using a built-in length function to check your string. It's absolutely crucial for checking user input, processing data, and validating those passwords.
Let's step it up a notch in Section 4, slicing, formatting, and splitting. And this brilliantly illustrates one of the absolute most vital concepts in all of programming, string indexing. Every single character inside a string has a specific numeric position, which we call an index. But, and this is a big but, notice carefully that computers do not start counting at 1, they start at 0. So in the word Python, the letter P is actually at position 0, the Y is at 1, the T is at 2, and so on. Understanding this zero-based indexing is a real game changer, because it's exactly how programmers efficiently slice out specific portions of text, like extracting just the area code from a massive list of phone numbers. We also constantly need to standardize our text formatting. I mean, imagine thousands of users entering their email addresses into your new app. Some use all caps, some use no caps, some mix it up. It's a total mess. Thankfully, both Python and JavaScript provide awesome built-in functions to instantly change string cases. You can convert entire strings to uppercase or lowercase with just one command. By quietly forcing all that messy user input into lowercase behind the scenes, we keep our data perfectly clean and formatted. Another really powerful trick is splitting strings. When we split a string, what we're usually doing is separating individual words based on the blank spaces between them. So we're converting one long, continuous sentence into a list or an array of completely separate data elements. This is heavily used in the real world. Think about it. If you type "best pizza near me" into a search engine, the system splits your string into an array of 4 distinct words and analyzes them individually to fetch the right results. It is literally the core engine behind modern search systems, data parsing, and chat applications.
All right, let's wrap up with Section 5, avoiding beginner string mistakes.
Okay, look at this. When name equals John is written without any quotation marks, we hit mistake number 1. And honestly, it is incredibly common for beginners. The programmer just forgot the quotes entirely. But without them, the computer has no idea this is text data. It looks at the word John and thinks it's a completely separate command or a different variable that it needs to go find. And when it can't find it, your program will instantly crash and throw an error. So the absolutely crucial point here is you must use your quotes. Writing name equals quotes John inside those double quotes tells the computer exactly what to do. It says, hey, this is just text. The text gets safely stored as a string variable, and the software runs perfectly smoothly.
And here is another major trap that can cause massive headaches down the line: confusing numbers and strings. Because 1, 2, 3, 4, 5 is wrapped in quotation marks here, it is a string, it's text data, it is not an integer. You cannot do mathematical calculations with it. If you try to multiply it or add it to another number, your code is definitely gonna fail. Understanding your data types, knowing exactly when a number is acting as math and when it's just acting as text, is incredibly important as you start building your own stuff.
We have covered so much ground today, from concatenation and slicing to zero-base indexing and dodging those common beginner errors. Remember, programming isn't just about math and crunching numbers. Handling text efficiently through strings is exactly what allows computers to actually communicate with us, process our language, and build those amazing interactive apps. The better you understand strings, the stronger your programming foundations become. So, I want to leave you with this final, thought-provoking question. As you start jumping in and building your very own applications, which string function do you think you're going to use the most? Think about it, maybe experiment a little, and keep exploring. Thank you so much for hanging out and learning with me on this explainer.
If you enjoyed this video and learned something new, like this video, comment your favorite programming language, subscribe to Future Break Coder, because many exciting coding and futuristic tech videos are